This is an experiment for BSc 6th semester interplanar distance. Then what is back diffraction? Two beams of identical wavelength and phase approach a crystalline solid and are scattered off two different atoms within it. The lower beam traverses an extra length of 2d sin theta. Now you are observing that this lower beam which traverses by an additional distance of 2d sin theta, then constructive interference occurs when this length equal to an integer multiple of wavelength of radiation. Then according to Bragg's law, it is given by 2d sin theta is equal to n lambda. So from Bragg's law, 2d sin theta is equal to n lambda, where d is the interplanar distance and theta is the glancing angle measured from the surface normal, and lambda is the wavelength of the incident wave. And this is the extra pattern which we are going to notice, and these lines consisting of L1, L2, L3, M3, M2, M1, etc. And these are the readings which are being recorded from the traveling microscope. And this is the traveling microscope, and the least count is to be calculated. And now the value of one main scale division is 0.05 centimeter, and the number of divisions on the vernier is 50 divisions. And the least count of this traveling microscope is given by 0.001 centimeter, which is said to be the least count of this traveling microscope. Now we have to record by focusing to each of this line on the diffraction pattern. We have to record these readings on the tabular column, which is represented as shown figure. Now this consisting of wavelength of X-ray given by 1.6 into 10 raised to minus 8 centimeter, and the for traveling microscope value of one main scale division 0.05 centimeter, number of divisions on vernier is 50, least count is 0.001 centimeter. And these are the tabular column which consisting of serial number, number of curves, reading of the traveling microscope when focused to left, middle and right, and A is equal to M dash plus R by 2, B is equal to M plus L by 2, and this is given by omega A minus B, and surface factor 2S is equal to A minus M or M minus B, and theta, D is the interplanar distance, A is the lattice parameter. We are calculating, and you are observing these are the readings which is being taken from the traveling microscope for the given diffraction pattern. And these are the number of curves we are observing here, and these are the readings of the left, middle and right. And finally we are calculating what is A and B, and we are calculating what is the value of omega. And now we can calculate what is the value of surface factor 2S, and mean 2S is to be calculated, and finally we can calculate what is the value of S, and theta, D and A. D is the interplanar distance, that is given by lambda by 2 sin theta, and A is the lattice parameter which can be calculated by using the relation D into square root of S mean. And this is the calculation for calculating theta, and theta is given by 2s pi into 57.296 by 2 omega, and that is given by 65.249, and d is equal to lambda by 2 sin theta. For the first reading it is found to be 8.8 into 10 raised to minus 7, and the lattice parameter is calculated. This is the lattice parameter which is given by d into square root of s mean, and is given by 14.93 into 10 raised to minus 7. Now the result is recorded. X diffraction of powder is studied, and the interplanar distance of a cubic crystal using X-ray diffraction is determined.